Hello and welcome to this video in which I will show you how you can specify and interpret a CTCM-1 model in the Mplus software. My name is Geiser, I'm an instructor with QuantFish. So first of all, what is a CTCM-1 model? A CTCM-1 model is a specific type of confirmatory factor model that is used to analyze multi-trait, multi-method data. Now, what is multi-trait, multi-method data? It is data obtained for multiple constructs or traits from multiple reporters. So for example, self-report, parent report, peer report, or there could be other methods such as, for example, an objective physiological test of stress versus a self-reported measure of stress. And so if you want to find out about convergent and discriminant validity of multiple methods with regard to a set of traits, then MTMM models are often used for that. And so one of those models, one of the CFA MTMM types of models is the CTCM-1 model. If you want to learn more about the CTCM-1 model and its structure, then I recommend that you first check out my other video that is called What is the CTCM-1 model on this channel here, so you can learn about the model structure first, and then you can revisit this video here where I show how to run this model in Mplus. So for those of you who already know the CTCM-1 model per se, but want to learn about how to specify it using Mplus, this is the video here that you should watch. So let's get started and let's take a look at the Mplus input file first. You can see here that I'm dealing with a single indicator CTCM-1 model where I have a design with 3 traits or constructs and 3 methods. The traits could be, for example, anxiety, extraversion, and happiness, and the 3 methods could be self-report, parent report, and peer report. And so then I have a design where each variable has an index for the trait T and also has an index for the method or rater here M. So I have YTM, those are my observed variables, and in the names list here you can see that results in 3 by 3 equals 9 variables, where Y11, Y21, and Y31 pertain to method 1, which is used as the reference method here in this example. So that could be, for example, the self-report of anxiety, extraversion, and happiness. And then method 2 could be the same traits measured by parent report, and then Y13, Y23, and Y33 could be the peer reports of the same 3 constructs. So it's a fully cross design with 3 traits times 3 methods or rater types. Next, we have the model statement in Mplus, and the model statement here first of all specifies the trait factors. Since we have 3 traits, we have 3 trait factors, T1 through T3, and so you can see that T1 loads Y11, Y12, and Y13. So those are the 3 indicators of anxiety. First is self-report, second is parent report, third is peer report. And then next is the second trait, for example, extraversion, again with the indicators from the self-report, the parent report, and the peer report. And then we have the third trait, for example, happiness, again measured by the 3 different rater types. Next are the method factors, and you can see that since method 1 serves as the reference method, we have only 2 method factors, one for method 2, the parent report, and one for method 3, the peer report. There's no method factor for the self-report, and that is one of the key defining features of the CTCM-1 model, that it does not specify a method factor for the reference method. And so that has as the consequence that we are contrasting the non-reference methods, here parent and peer reports, against the self-report. The self-report is our gold standard here, and that is what defines the meaning of the trait factors. And then we can look at how the parent and peer reports deviate from the self-report. And mathematically, this is done by defining the method factors as regression residual factors in a latent regression analysis. So M2 and M3 are, technically speaking, regression residuals from a latent regression of the other reports on the self-report. And so those regression residuals then characterize what is left over, so to say, after we account for shared variance with the self-report. So to which extent are, for example, parent reports unique unique relative to the self-report, and to which extent are the peer reports unique relative to the self-report. That's expressed by M2 and M3. Those are residual factors. And the residual factors M2 and M3 can be correlated, and so can the trait factors. So that's why it's called a correlated traits, correlated methods -1 model, because trait factors are allowed to correlate and method factors are allowed to correlate. And we'll see later on how those correlations are interpreted when we take a look at the Mplus output. Now, there are certain types of correlations in the CTCM-1 model that are not allowed, and those are the correlations between the trait factors and the method factors. And that's because the method factors are defined as regression residuals, and regression residuals are by definition uncorrelated with their regressors or independent variables. And so therefore T1, T2, and T3 may not be correlated with M2 and M3. So we have to fix those correlations to 0, as is done here. Otherwise, Mplus would attempt to estimate those, and that would lead to not only identification problems but also interpretation problems, because we cannot have correlated traits and correlated with, or we cannot have the traits be correlated with the methods in this model. Otherwise, the interpretation and meaning of those factors would be compromised. So those you have to think of to put those 0 correlations into your specification to not allow those types of correlations. The other types of correlations are fine. Traits can correlate, methods can correlate, but not traits with methods. And so that's all you need to specify for this CTCM-1 model. So let's take a look at the output file. And so I'm going to scroll down here. You can see that this is based on a sample of 500 observations. And when we can take a look at our fit statistics, we can see that the chi-square fit statistic here is not significant at the 0.05 level. The p-value for our chi-square is 0.2884, as you can see here. So the model is not rejected at the 0.05 level, meaning it fits the data well. Also, the RMSEA coefficient looks good here. CFI and TLI also look good, and the SRMR value is also pretty small. So the model fits the data well, so we can safely interpret the parameter estimates. Now, with regard to the CTCM-1 model, the unstandardized solution that you can see here is often not terribly interesting. So we can really gain more information from the standardized solution, specifically the completely standardized solution where all observed and latent variables are standardized. And so I'm going to go down right away to the standardized solution here, which in Mplus is STDYX. STDYX means it's the completely standardized solution where all variables, including observed and latent variables, are standardized to variances of 1. And so then first we can find the standardized factor loadings here on the trait factors. And so notice that the first variable, Y11, so that would be the self-report of anxiety, has a pretty strong loading on T1, that's 0.891, showing that this is a reliable measure of this factor. And that should be the case because T1 is the anxiety factor as defined by self-report. So this loading basically tells us that this is a fairly good measure of self-reported anxiety in the sense of reliability. So 0.89 squared would be the reliability coefficient. So about 0.9 squared, so the reliability is about 0.8, 0.81. So that's a good reliability value for a variable, and we'll see that later under the R squared measures that are given also by Mplus. So this is the standardized loading of the self-report for the anxiety factor, and that basically just tells us it's a reliable indicator of self-reported anxiety. And then next we have the loading of the parent report anxiety measure, and that loading is smaller. So you can see that 0.66 is still a substantial standardized loading, but it's substantially smaller than the self-reported loading here. And so this indicates that there's not really amazing convergent validity between parent and self-reports here. You can see that when we have a coefficient of 0.6, if we squared that, that would be 0.36, so it's a little bit more than that. So, but less than 40% of the variance in this measure is accounted for by the self-report trait factor. So there's somewhat convergent validity here, somewhat of a convergence, but it's not super high. And then the peer report measure of anxiety has an even smaller standardized loading on the reference factor, indicating that there's even less convergent validity between peer reports of anxiety and self-reports of anxiety. Next is the second trait. So this could be extraversion, for example. And again, the self-report has a fairly decent standardized loading, indicating fairly reliable measurement. Here it's not as high as for the first trait factor, but still it looks pretty good. And then the parent reports have also relatively strong loading, 0.725, but again it's smaller than the self-report, indicating that there's some discrepancy between parent-reported extraversion and self-reported extraversion. And the peer report variable has a loading of 0.605, so again showing somewhat weaker convergent validity than the parent reports. And the pattern is pretty similar for the third trait here as well. Again, the self-report has a strong loading indicating high reliability. The other ones are somewhat lower. Now in practice, we often find even smaller loadings of the non-reference methods on the reference factors, because oftentimes when we have multiple rater studies, the other reports will not converge as strongly with the self-reports, or overall, reporters will not show high agreement, especially when it comes to rating psychological traits that are less visible, such as depression, anxiety, something that's more internalizing, that are internalizing problems or internalizing issues, emotions, feelings that are difficult to see maybe for others. Then we don't find very high standardized loadings of other reports on self-report factors. So these standardized loadings, in summary, are directly related to convergent validity. They tell you something about the extent to which non-reference methods converge with the reference method. Here, it's fairly decent. Often in psychological studies, we find lower standardized loadings than we can see here for the non-reference methods. Next are the method factor loadings on M2 and M3. Remember that M2 is the parent report method factor in this example, and M3 is the peer report method factor. And so you can see that the loadings here on the parent factor range between 0.36 and 0.49. They're not super high. Oftentimes we see higher method loadings than that. So that indicates that here convergent validity is relatively good relative to method specificity. Also, we can see that the peer report method effects are somewhat stronger than the parent report method effects, with the loadings being somewhat higher. So there is a higher amount of discrepancy between the self-reports and the peer reports here compared to parent and self-reports. Next, you can see the correlations that we set to 0, and those are between the trait factors and the method factors for T1 and T2, and then also the correlations between T3 and M2 and M3 also have been set to 0. It's important to check that, because otherwise the interpretation of the method factors as regression residuals would be compromised. So that's good that these are 0. They should be. What is not 0 and usually shouldn't be 0 are the trait correlations. So T1 and T2 are fairly highly correlated, 0.68 here, so that's probably not realistic if we use anxiety and extroversion as an example, because typically probably extroversion would be negatively correlated with anxiety. So that's maybe not a realistic example here. This is simulated data, so it does not conform to actual data that you might see in practice. Also, you can see that trait 3 and T1 are correlated 0.49 and T3 is correlated 0.41 with trait 2, indicating fairly decent discriminant validity. Those traits are not super highly correlated, and depending on what you're measuring, this could indicate that there is satisfactory discriminant validity between those 3 traits as measured by self-report. Also, we get the correlation between M3 and M2, so that is the correlation between the parent and peer method factors, and that correlation indicates that the method effect generalizes, so to say, across these different raters, or we could say parent and peers have a shared perspective that deviates from the perspective of the self-report, because remember that the method factors reflect views of the parent and peer raters that is distinct or that is not shared with the self-report. And so if those 2 method factors correlate, then this shows that their unique perspective is shared with one another. So parents and peers share a common view that is not shared with the self-reports. And that's something that we often see. So oftentimes we have a correlation between the method factors for the non-reference methods because they share a common perspective. So that's very common, and therefore this correlation is desirable, or it's not necessarily desirable, but we should estimate it, because if we don't estimate it, then the model would be misspecified. What else can we find in this output? At the very end, we get R squared, and so R squared gives us the reliabilities of the indicators. You can see that these vary from pretty weak to fairly good, so they're between 0.527 and 0.853, indicating modest, or well, we could say pretty weak reliability, especially for the indicators pertaining to the peer reports, and then up until pretty good reliability for the self-reports here in this example. I hope you found this demonstration useful to learn more about how to specify and interpret a CTC-M-1 model in Mplus. If you want to learn more about multi-trait, multi-method, and multi-rater analysis with Mplus, check out my workshop that you can find in the description below this video. Also, you can find other resources there, including workshops, and you can subscribe to our weekly newsletters as well. And I hope I will see you next time again when we have our next stats tutorial up here on the QuantFish channel. Take care until then.